Hello everyone. First of all, I would like to thank Blockchain Lane for organizing this very special event, and first and foremost, all of you for coming here today. I have the pleasure today to tell you a little bit about the company I'm working with, Parity Technologies, what we do, where we come from, how we are looking at the space, and why I think that should be interesting to you. So a little bit about who we are and where we come from. Parity Technologies is an infrastructure and innovation-focused company building platforms and applications. We were founded 2 years ago in UK, London, by several key alumni of the Ethereum Foundation, most notably Dr. Gavin Wood, who was the co-founder and CTO of the Ethereum project, and now heads our technical development. Over the last 2 years, we have grown to a team of over 30 developers that include experts in cryptography, consensus system, peer-to-peer technologies, and we have offices in London, in Berlin, and Moscow, and quite a few people in Oslo. So whenever you get there, please visit us. What do we do? Well, at Parity Technologies, we have a vision for a decentralized Web3 that proposes a set of interrelated peer-to-peer technologies that together facilitate the development of decentralized applications and support to build these kind of systems that are capable of resisting very comprehensive attacks. Today, we focus mostly on building the most advanced and most widely deployed blockchain software. On one side, we live and we breathe open source. So most of you probably know us. Probably from our Ethereum implementation, which is the Parity Ethereum client. But earlier this year, we also released a Bitcoin client, which is called PBTC. And I think that made us actually the first team in the world that has implemented both a production-ready Ethereum client and Bitcoin client. But what I think is quite interesting to know is how we look at that. So we are not dogmatic at all. We try to stay away from this political discourse in this place and really look at what makes sense from a technological point of view, so technology innovation. That said, for Parity Bitcoin, Parity Bitcoin doesn't favor any scaling solution, no scaling approach or no specific chain fork rule, but rather allows the user to decide what kind of version of Parity Bitcoin they want to run, right? If it's Bitcoin Core or Bitcoin Cash or Secret 2x, we don't care. Last but not least, my colleague Peter had the chance to introduce you yesterday a little bit to Polkadot, which is our take on a heterogeneous multi-chain approach. And I might tell you a bit about that later today. On the other hand, besides all these open source stuff we do, we support enterprises with their blockchain initiatives. So to help leverage these very special technologies to solve some of their problems. And most of these problems they've been unable to solve with the conventional client-server architecture, and that's where we come in. Some of them that I've listed, those are the most recent one, which is, for example, a project with Energy, where Energy is leveraging our technology to build a peer-to-peer car charging, electric vehicle car charging infrastructure. That currently, I think they have currently over 1,000 charging points deployed in Germany, and in Germany alone, and they are built on top of this Parity Ethereum client. Another one is our project with the UN World Food Programme, which was implemented earlier this year. It allows currently the UN, the United Nations World Food Programme, to distribute financial aid cash vouchers and food vouchers to, I think, currently 50,000 refugees in a Syrian refugee camp in Jordan. And we are in the process of extending that, I think, to roughly 500,000 people over the next year across the whole region. Last but not least, there's a project where we are very engaged in, which is the Energy Web Foundation. It's a major non-profit organization that looks into leverage blockchain to really disrupt and enable the energy space to leverage renewable technology, renewable energy technology. So, brief overview. Parity Ethereum, our Ethereum implementation and Rust. Highly performant, very reliable. It's fully compatible with the public Ethereum mainnet, but it's a lot more beyond that. So it's not just what you know about Ethereum right now. It's, so to say, Ethereum Plus. Second, Ethereum browser, which is really the way that it's an interface into that world for both developers on one hand and users on the other hand. So it helps or allows developers on one side to manage and deploy their decentralized applications. And on the other side, it allows users to navigate the world of this new world of decentralized applications built on top of Ethereum. And one point I want to really point out is the abstraction in the core. So whatever we develop, we really take the approach that we say it should be as modular as possible, as versatile as possible. And what we introduced as the first one was, or the only one, was abstraction in the core. Currently, you don't even have to modify Parity Ethereum, the software. You can just pass some parameters to it to run really diverse different chains and spin them up. So it doesn't create much overhead at all. For example, if you only look at the public blockchain space, currently you can run the Ethereum, the foundation launched Ethereum mainnet, Ethereum Classic, or Expand with the same kind of software. But what I wanted to talk about today mostly was why I think that what we've built over the past 2 years should be really interesting for enterprises. And through these projects that we have participated in over the last 1 year, 2 years, we've seen certain requirements and needs that are unique to the enterprise space and not so much to the public blockchain space. And I want to walk you through these points point by point. So there's alternative consensus mechanisms, there's privacy and permission features, there's deployment tools. You see they have low hardware requirements, and last but not least, most of them need interoperability between chains. So first point, alternative consensus mechanisms. As you all know, the consensus engine, the consensus mechanism is really the heart of every blockchain system. And this has a lot of effect on the security properties of your software, of your blockchain network, blockchain system. And security in blockchain systems really resolves around the point that you try to distribute trust among multiple parties with really disparate interests. That is what you try to achieve. In public blockchains, how they do it, is with proof of work, which most of you know. So you lower entry barriers to a degree where you only kind of need some hardware to participate in the validation process of the system, to maintain the integrity of the system. Well, what we've seen in all these enterprise use cases is that this is not really what they need, because in most of these settings, it's quite straightforward to identify a few or a limited number of parties, entities that can be trusted. And proof of work is really not suitable for that. It's really wasteful, it consumes a lot of energy, and you can't really control who participates in the validation process. So what we did is we abstracted again, we modularized again, and allowed our implementation to take multiple consensus engines in. And currently, Parity Ethereum features 3 or 4 consensus engines. First and foremost, obviously, that's ETHash, which is a proof-of-work consensus mechanism which is used for the public Ethereum mainnet and all the others. But also, and this is really interesting for you guys in my opinion, this is Aura, short for Authority Round. It's a really simple and fast proof of authority or proof of stake consensus mechanism. Last but not least, it was designed and implemented by us. And another one is Tendermint, which is a PBFT, proof of authority and proof of stake consensus mechanism, designed by the guys around Tendermint, Jake Cron, who's here today as well, and implemented by us. And we are in the process for implementing more. But what we have seen is that Aura really fulfills the need and requirements of all use cases in an enterprise environment we have come across. So another point is privacy and permissioning needs. Well, this turns around the question, hey, who should see what is actually happening in the system? Who should see that I transacted with this other person, or that this company transacted with that other company? And the other thing is permission. So, permissioning revolves around the question, who can do what in the system? So, what kind of role can a participant take? Should they only connect to the network? Should they validate? Should they be able to send transactions? And so forth. And often this is just conflated to one thing, like permission chains. A lot of these companies talk, you just need a permission chains. But permissioning is a really delicate thing because it can be introduced on different layers, and that's what we've done. And I want to walk you through these layers. There's first the networking layer, the validator set layer, transaction type layer, and gas price layer. So for network, we've implemented a feature that allows you to force arbitrary network topologies on your network. That means you can decide which node should connect with which other node, or through which other nodes, for every single node. And the most interesting thing about that is that it's implemented with reference through a smart contract. So basically you can have a governing body in your network, let's say a consortia or the board of a consortia, who decides how transactions should flow through the network and who should see what. Another one is a very, very important one, the validation part. So who maintains integrity in the system and how should these entities change? So let's assume this is a consortia, a few companies, each of these guys are a validator, they validate transactions with or an efficient proof of authority consensus mechanism. So they need a way to, let's say, add and remove validators, a new entity. So what we've done is we've implemented again with an interface through a smart contract that allows you to force arbitrary rules on these kind of validator set changes. So for example, you can have a rule implemented that says existing validators have to perform a majority vote to introduce a new validator to the set. Another one is transaction permissioning, so transaction type permissioning. So what participant, what user can do what in the system? Should the user only perform a simple transfer, or should they be able to create smart contracts or to interact with certain smart contracts? We've implemented in a way that you can specify it per address. That is, you can have some kind of memberships in your consortia, or say like, hey, you know, this user should only do simple value transfers, or whatsoever. Another one is setting gas prices individually. I'm not sure how aware you are with the notion of gas in Ethereum-based blockchains, but basically it's a spam prevention mechanism and a mechanism to allow these validators to be compensated for their computational efforts. And what we've done is you can have a smart contract that says, okay, this account has to pay that much for these kind of interactions, or this other account doesn't have to pay at all, which is really interesting for some use cases. Another one is privacy features. And here it becomes also quite interesting. What we've done, especially earlier this year, was implementing a new piece of core technology that hasn't been implemented today. We call it a secret store. This piece of core technology enables you to have distributed key generation, key storage, and threshold retrieval. It's, so to say, a multi-sig for keys that can be leveraged to enable all these permissioning and privacy features. To talk about privacy features, what we have are encrypted transaction and contracts. So, you can have specific special contracts where only the parties that are involved with that contract or with that transaction can see the details of that contract or that transaction, plus a few secret validators who you potentially can name yourself, you as the parties that are involved in the transaction. This is a little bit, we try to illustrate it here a bit. So, a last thing are deployment tools. We've gone down the road to build a tool that we call Parity Deploy, that is really a tool for generating ready-to-deploy solutions, either for testing purposes or production purposes. So you can specify what chain it should be, what consensus mechanism, how all these different characteristics of the network should look like. You press a button and it spits you out of ready-to-deploy solutions. So let's say Docker container for production purpose, for testing purposes, and whatsoever. You can also say it should include some monitoring tools, such as a Block Explorer or something we would call Parity Watchdog, which really watches the blockchain for abnormalities and would notify in case there's something bad going on. And last but not least, obviously benchmarking to have continuous improvement in your systems. Another thing is, another requirement are these needs for low hardware requirements of that software. So what we have are three different types of clients. This is a full client, which has a very conservative footprint but allow for a maximum security level. We have a light client, which is more compute and storage light, but bandwidth intense, that to say, and it features a consensus-based trust. Last but not least, we have a thin client, which has a minimal footprint and it really only needs on the client side to have a browser running that supports HTML5 and WebAssembly, and that's it. But that said, you need trust in RPC. That's a trade-off. And last but not least, we get to interoperability between chains. What we have seen over these past years is there will not be one chain to rule them all. And we know that enterprises will not go on public blockchain nowadays. And this is completely understandable. They need sovereignty over the validation part of their systems. So what we are looking at is we support enterprises or consortia to deploy these proof of authority permission systems, but at the same time, we can give the promise that it's only a matter of time until these systems will be able to communicate with all these other permissioned private networks or even public networks in a trustless way, in a very efficient and trustless way. So our first step was implementing a bridge. So what you can do today is you have your Ethereum-based, Parity Ethereum-based enterprise consortium network, private permission. But what you can do is you can connect it over a bridge to the main public Ethereum network, and within that private permissioned consortium blockchain, you can hold real Ether. So you kind of make it interoperable, which is really powerful. And the vision we have is bringing that to a point where this is a lot more generalized, where we have Polkadot, which Peter talked about yesterday. Hopefully in a few years, let's say 2-3 years, where we have an extensible heterogeneous multi-chain that allows all kinds of diverse chains such as Zcash, Bitcoin, Ethereum, or some kind of chains we don't even know how they look like today. They will be able to interoperate and talk to each other and live within the same network. Here, to finish up, I brought you a little overview of our tech stack, where you can see what we have today and where we are working on. It includes blockchain technology for trust-free computation, IPFS for content addressable storage, also Whisper for privacy-preserving messaging, and a lot of other stuff on the middleware layer and the application layer. Thank you very much.